For all of human history, we've treated aging as a certainty, right? Like taxes or the sun rising. But what if it isn't? Okay, let's just dive right in because this new field called geroscience is flipping that entire idea on its head. It basically says, hey, maybe aging isn't our fate. Maybe it's more like a really, really complex engineering problem, one that we can understand, manage, and maybe, just maybe, solve.
And that right there, that's the million-dollar question, the one that's driving this whole revolution. I mean, think about it. We spend trillions of dollars playing this endless game of whack-a-mole with individual diseases, cancer, heart disease, Alzheimer's. But what if we could stop playing that game and go after the one thing that's the single biggest risk factor for all of them? What if we could target the process of aging itself?
So, this is the fundamental shift in thinking. The old way is totally reactive. You wait for something to break, then you try to fix it. The geroscience view, it's proactive. It says, look, by going after the fundamental biology of how we age, we could potentially delay or even prevent all of these diseases at the same time. This is a huge leap. It's about moving from treating sickness to actually engineering health.
Now, to even begin to tackle a problem this big, scientists first needed a map, a detailed blueprint of what's actually happening inside our bodies as we get older. And that blueprint is built around something they called the hallmarks of aging.
And here it is, the map, the 12 hallmarks of aging. Now, don't worry, you don't need to memorize all this. The key takeaway is how scientists have organized the problem. They've sorted it into 3 main stages. It all starts with the primary hallmarks. That's the initial direct damage happening to our cells. Then you've got the antagonistic hallmarks, which are actually our body's defense systems trying to respond, but over time they start causing problems of their own. And finally, you get to the integrative hallmarks, which is basically when the whole system starts to buckle under the weight of all that accumulated damage.
So, the primary hallmarks are where the trouble really begins. You can think of these as the first cracks in the foundation. We're talking about tiny errors piling up in our DNA, the little protective caps on our chromosomes called telomeres getting shorter every time a cell divides, and our cells' basic quality control systems starting to fail. This leads to a bunch of junk proteins building up because the cell's recycling program, known as autophagy, just isn't keeping up anymore. This is really the root of the entire damage cascade.
Okay, this next stage is fascinating because these antagonistic hallmarks actually start out as good guys. They're your body's defense mechanisms. Take cellular senescence. It's a process that forces a damaged cell to stop dividing so it can't become cancerous, which is great. The problem is, when these defenses are stuck in the on position for decades, they totally backfire. These senescent cells, or zombie cells as they're often called, hang around and start spewing out a ton of inflammatory gunk that damages all the healthy tissue around them.
And that brings us to the final act, the integrative hallmarks. This is where the damage from those first 2 stages just completely overwhelms the body. Your supply of stem cells runs low, so you can't repair tissues effectively. Communication between different systems breaks down, and you end up with this constant, low-grade, simmering inflammation throughout your entire body, a state now known as inflammaging, which basically acts like a massive amplifier for everything else that's going wrong.
This inflammaging idea is so critical, it's worth taking a quick look at how it works. It's a really destructive, vicious cycle. So as our cells get damaged, little bits of our own DNA can leak out into places they shouldn't be. An enzyme called CGAS sees this DNA and thinks it's an invading virus, so it sounds the alarm. This triggers a protein called STING, which is kind of like the cell's emergency broadcast system. STING then kicks off a massive inflammatory response, creating this relentless flood of damaging molecules that just fuels a fire of chronic damage all over the body.
So, okay, now that we have this blueprint of decay, how do we start to fight back? Well, this brings us to the really exciting part, the cutting-edge therapies that are being designed to target these hallmarks directly.
And the anti-aging arsenal is actually incredibly diverse. On one side, you've got drugs that are already on the market for other things, like the diabetes drug metformin or the immunosuppressant rapamycin. Scientists are now repurposing them to target aging pathways. But then on the other end of the spectrum, you have these truly futuristic technologies, like epigenetic reprogramming, which have the wild goal of literally turning back the clock inside our cells.
Let's just take metformin for a second. The evidence for its potential is, well, it's pretty staggering. A huge analysis of postmenopausal women with diabetes found that the ones taking metformin had a 30% lower risk of dying before age 90 compared to those on other diabetes drugs. Let that sink in. A 30% lower mortality risk. That is a massive, massive signal.
Now, the story with rapamycin is a bit more complex, and honestly, it's a perfect example of how science really works in the real world. There was a recent human trial called the Pearl trial, and its main goal was to see if low-dose rapamycin could reduce that dangerous fat around our organs. And on that one specific measurement, it didn't quite hit the mark. But, and this is a huge but, here's the twist. While it missed its main target, when they looked at secondary outcomes, they found something incredible. The group that took a 5 milligram dose reported a statistically significant improvement in their overall general health. And what that number, that p-value means, is that this result is highly unlikely to be just a random fluke. It suggests the drug is having these broad positive effects, even if it wasn't the one thing researchers were originally looking for. And then we get to what many consider the holy grail, epigenetic reprogramming. I mean, this is the technology that's really aiming to reverse aging. The idea is that by briefly switching on a specific set of genes called Yamanaka factors, scientists can literally wipe the slate clean, erasing the epigenetic marks that build up over time. It's like rebooting a cell's computer back to its factory settings, making it young and healthy again without losing what makes it a skin cell or a neuron. And if you're wondering just how seriously this is being taken, just follow the money. One single company focusing on this research, Altos Labs, launched with an unbelievable $3 billion in funding. $3 billion! This is not some fringe science in a dusty lab anymore. It is one of the most heavily funded areas in all of biotechnology, period. And Altos is far from alone. The clinical pipeline is just exploding right now. You have companies like Life Biosciences and Turn Bio that are already starting human trials for therapies to reverse certain types of blindness and to rejuvenate skin. Then you've got others like Rubido, which is going after those toxic zombie cells with drugs called senolytics. And they're using this really clever prodrug system where the medicine only activates inside the zombie cells, which makes it way safer for the rest of the body. The point is, these treatments are moving out of the lab and into people right now.
So with all this mind-blowing science moving so fast, you'd think these cures are just a few years away, right? Well, it turns out the biggest roadblock we have left isn't biological at all. It's bureaucratic. And here is the core of the problem. The FDA, the government agency that has to approve any new drug, officially does not consider aging to be a disease. Their stance is that it's a natural process. And here's the catch-22. If aging isn't a disease, you can't get a drug approved to treat it. It's a regulatory brick wall. But of course, there's a plan to get around this. A really important clinical trial called the TAME trial, which stands for Targeting Aging with Metformin, was designed specifically to break this very logjam. The goal of TAME is actually brilliant. It's not trying to get metformin approved for aging. That's a non-starter. Instead, it's designed to prove that this one single drug can delay a whole cluster of different age-related diseases all at once. If it works, it'll hand the FDA the hard data it needs to finally recognize aging itself as a legitimate, treatable condition. And that would blow the doors wide open for this entire field. Okay, so let's say we do it. We figure out the science, we get past the regulations. Where does all this lead? What is the ultimate ambition here? What's the endgame? This is where the science crashes right into some very deep, very old philosophical questions. On one side, you've got bioconservative thinkers like Leon Kass, who argue that knowing our time is limited is what gives our lives meaning and urgency, and that trying to conquer death is just arrogant. But on the other side, you have advocates like Aubrey de Grey who say no, aging is simply a disease, the worst disease there is, and we have a moral obligation to cure it, just like we would with any other awful illness. And the ultimate scientific goal? It has a name that sounds like it's straight out of a sci-fi novel: longevity, escape, velocity. This is the hypothetical tipping point where, for every single year you manage to stay alive, science comes up with new treatments that extend your healthy life by more than a year. If we hit that point, you could theoretically outrun aging forever, repairing the damage faster than it can build up. And that's really the final thought to leave you with. Forget just living to be 100 or 120. If we actually achieve longevity escape velocity, if science can add a year to your life for every year that you live, what would that mean for us, for society, for our families, for the very definition of what it means to live a human life? What would our world even look like? It's a question we might all have to start answering a lot sooner than we think.